Hello, LSCT's online students exhibition. My name is Wee Zhern Ray, a final year chemical and biomolecular engineering student in MP, and today I will be showcasing you my research project, the development of a new generation of organic solvent nanofiltration membrane to a unique chemical cross-linking approach. So to start off, right, I remember in secondary school because I took bio, the first thing I learned about membranes was its definition. Until now, I still remember it because of O levels. So it was a 3 mark question. So the definition is right, a partially permeable membrane where molecules flow from a high concentration to a low concentration across, and the third mark is very important, across the concentrating gradient. So in poly, right, I learned that it was so much more than that. So I'll explain to you how I got interested into membrane research. So to first explain to you how I got into this project, I first joined YSIG in year 1 and was mentored by Dr. Noah Shi. YSIG gives students a chance to participate in active research and gain scientific knowledge. So if you're keen to solve opportunities like this, to venture out into the scientific field, you should definitely join this. With YSIG connecting me to these research opportunities, right, I sought to be under Dr. Xiong's research project as I was highly interested in the field of membrane science which he specialized in. I also presented our research findings in a conference in Malaysia, and the presentation was fortunately awarded the gold grade and third place overall. I also created a research project in research poster in a local chemistry conference, and our poster was awarded as one of the winners. Now, onto our research project, right? Our research project is on developing new ways to reduce the size of our pores in our membranes. So there are 4 general steps in our membrane research: spinning, potting, cross-linking, and testing. So to help you visualize the concept better, right, you can imagine doing membrane research to be like baking. Firstly, there's the spinning, where we combine ingredients in a formulation, right, to create our nanofiltration membranes. So similar to how we mix like raw ingredients like flour, right, and water, right, into processing machines, then we have the dough, right. So secondly, there's the potting. We place thin fiber-like membranes which we created beforehand into a tube to allow for higher volume that our membranes can process, and also leads to high efficiency in our next step, which is cross-linking, where we place these molecular meshes, right, onto our membranes to reduce the pore size. So you can see that our size of our pores, right, decrease from 1 nanometer to 0.5 nanometers. So this is the illustration, right? So we have the membrane, we have the pores, and we have the mesh. Then we combine them together, and our effective pore size essentially decreased. So if you measure it in terms of NWCO, which is the molecular weight cutoff, right, our molecular weight cutoff decreased by more than 10 times, which means that the threshold, right, the number of molecules, right, which is until our molecular weight cutoff, right, increased by more than 10 times. So now onto testing, right, we can finally test our membranes to measure their performances with parameters such as water flux and salt rejection. So these membranes, right, are useful to obtain API, which are active pharmaceutical ingredients that have low molecular weight. API is important as they act as intermediates in making many pharmaceutical drugs like paracetamol like that. So it is not also limited to pharmaceutical applications. Advancement in our membrane technology, right, will also be useful in water filtration processes, agriculture and food, and also industrial gases removal. Onto my personal experience, right? My first few days, I built and assembled the foundation for the water system by scratch. You need to cut the metal tube with a saw by hand, tube fitting each and every bolt and knuckle, and ultimately assembling it onto the main testing station. So it's pretty cool, right? So if you're looking to do more practical, hands-on work, this is your best chance. From the spinning, where we can optimize the formulation, the potting, and basically everything. These are engineering optimizations and know-hows which you can learn now. So for the people who I worked with, right, there are Dr. Xiong, Dr. Su, and Sheng Qin, and also other interns which I worked closely with in this project to make this possible. Uh, so, as I mentioned before, I presented our research findings in the conference in Malaysia, and the presentation was awarded the gold grade with third place overall. I also created a research poster. The link is below. You can go check it out. Uh, we were awarded as one of the winners. So this experience have proved to be immensely valuable to me in obtaining knowledge and experience of how research would be like. I hope this video showed you some insight towards membrane research. Thank you. These are my socials. If you want to find out more about my experience, feel free to contact me. Thank you.